Welcome to Team Voltron. It's another season of Deep Racer. Looking forward to reconnecting with our fans. Welcome and enjoy. Hello everyone. A subscriber of mine asked me about hyperparameters, specifically discount factor. He asked me to make a video about this. I wanted to share with you my approach on how I look at hyperparameters. So let's look at one. I'm looking here at the AWS documentation. It explains how to systematically tune the hyperparameters. If I scroll down here, you'll see it talks about the hyperparameters and their effects. Let's focus on discount factor. So this says a factor specifies how much of the future rewards contribute to the expected reward. The larger the discount factor, the larger the discount value is, the further out contributions the vehicle considers to make a move, and the slower the training. With a discount factor of 0.9, the vehicle includes rewards from an order of 10 future steps to make a move. With a discount factor of 0.999, the vehicle considers rewards of an order of 1,000 future steps to make a move. The recommended discount factor values are 0.99, 0.999, and 0.9999. So what does that even mean? And what do the quote-unquote pros use? Well, I'm not a pro. I hope to be a pro, but I can tell you what I've done. So first of all, I like visualizing this, right? What does this even mean? What does it even look like? So why don't we graph it out? So I like this website, geogebra.org.calculator, right? Shows you a whole bunch of, it lets you plot out your own function. So I'm going to put 999 to the x. That's essentially what this function is doing. So if I change the axes here, the minimum is going to be -1. The maximum will be 1,000 steps. This function could be from 0 to 1 to 1. So just to make it look pretty, I'm going to make it -1 to 1. Here we go. So you can see that as the number of steps increases, so imagine the x-axis to be number of steps, the contribution of that reward diminishes, meaning the most recent step, step 0, is weighted by 1, so it gets the full value of the reward. But 500 steps away over here, you're looking at 60%. So 60% of that reward contributes to the total reward at that point. That's how I'm interpreting this. I could be wrong, but this is how I've interpreted it. So what do the other plots look like? So 0.999 to the x was the first discount factor. Let's look at 0.99 and 0.9. Right, so 10 points is around here somewhere. Let's zoom in. Right, and then 0.99. So you can see if you use a discount factor 0.9, it's only using a handful of steps to calculate the reward. So that means if you're going around the turn, it's really just looking at the immediate steps before it to decide whether or not, to decide the value of the rewards at that point in time. So what does that mean? If you use something 0.999, look how far out this goes. All the way out. That means it's considering all of the rewards, all the steps, all the rewards and all the steps. So this could be a problem, right? It means if you're zigzagging or if your reward function tends to zigzag a lot, it's going to count all that a lot more. Meaning if you zigzag a lot versus a lap where there's very little zigzag, there's going to be a lot more points, a lot more rewards, usually, right? If you zigzag more because you're taking more steps. So with a high value for discount factor, you're going to end up rewarding reward functions that promote zigzagging. And that's why if you overtrain, meaning if you let the training function train for a long period of time, sometimes people see the performance get worse, more zigzagging. It's because of this discount factor. All right, so I'm going to skip ahead. I plotted out a few charts. And if we take the documentation of face value that says that let's go back to the documentation, that a discount factor of 0.999 gives you an order of 1,000 future steps. I basically plotted that out, looked at where 1,000 intersect that line, and it's at y equals 0.3666. And I used to assume, all right, as a rule of thumb, where does that line intersect the other discount factors? So for 0.99 to the x, so discount factor of 0.99, that's about 100 steps. And again, that's I've read that documentation. Okay, that makes sense. At 985 to the x, you get 66 steps. At 0.98, you get 49, let's say 50 steps. And I think this is ridiculous, but we'll put it up anew. I don't see how this could work for anyone, but you never know. Maybe someone got it to work. 0.9 discount factor, you're looking at basically 10 steps, just like this line suggested, right? So by graphing it out, we kind of can see how the rule of thumb works. So what I'd like to do is think about, okay, how many steps does it take for me to go around the curve? So if I look at my log analysis, this is a plot of all the steps, right? And you can look at the actual data chart, but just to give you a sense, what I'm trying to do here is I say, okay, if the car is here and I want to make this turn, or let's actually look at this hairpin, this not a hairpin, but this 90-degree turn here. Let's say the car is right over here. How many steps does it take for me to make it all the way around, right? Because I want to make sure that the car isn't going to crash. If I make it too short, it may just find that the best path forward is to drive off the road, right? If it's too long, I'm going to get zigzag. So I like to say, okay, from here to here, like this segment here, how many steps is that? And if it's around 100 steps, I go back to my chart and say, all right, which discount factor is going to give me 100 steps? So for example, here, the discount factor would be, let's see, which one is this? This line is 0.99 if I want to aim for 100 steps. Again, that's just the way I do it. That's my heuristic. Other teams might do other things, but this is how I've interpreted the discount factor. So what does it look like in real life? Well, you know what? I did some training last month on the Rogue Pro track. And let's see here. So this is, let me just walk you through what I did here. I did a couple of experiments. One was my reward strategy was literally one line of code, return speed. The best training lap times I got here were 33 seconds after about 22 hours of training time. Then I tried return speed, but with a different action space, and I shaved off about 3 seconds, right? So that was pretty good. Then I followed a centerline reward strategy, and look at this. I started, around 40 to 45 second lap times were like the best that I could see. Again, this is like the better laps that I saw in my training. By switching to 0.98 discount factor, just that's the only thing I did differently. It reduced the time from 40 seconds to 33.5 seconds. So I shaved 7 seconds off with this different discount factor, right? So that really helped. Now keep in mind, I am training for 9-10 hours at a time, mostly because I do this at night. I let it run overnight. I don't have time to be babysitting this. I can afford to do this because I'm using my computer and I'm doing local training. So I'm not paying AWS all this money. I'm just using the computer that I have at home. Now, then I tried to change it to 0.9 discount factor, even more aggressive. Again, that's only 10 steps. Failure. After 42 hours of training, it never completed a lap, right? So that discount factor was way too aggressive. And again, let's go back to the graph, right? 0.9 is only looking at, 10 steps, right? So that clearly was not enough for it to resolve, to really learn how to get around the curve. It was just not enough reward data to do that. So essentially, the model was getting rewarded for running off the track, right? Just crashing every time. So anyway, 42 hours burnt there that you don't need to waste on that, right? So hope this was helpful. Gave you some ideas on how to think about your discount factors. Again, this is what I did. Your mileage may vary. Have fun out there, and let me know in the comments if this was helpful or not. Looking forward to hearing back from my subscribers. Thanks. Bye bye. There you have it, folks. Team Voltron. Stay tuned for more. Make sure to subscribe and click that like button if you want to see more of this content.